Hi everyone! Today we're going to be talking about fixed points. Okay, so to start, let's consider a simple differential equation. dp dt equals p times 1 minus p. Alright, so this left-hand side, dp dt, this is going to answer the question, how does our current population change? Right, and this right-hand side, p times 1 minus p, this is just a function of our current population. Okay, so we already know that the sign of dp dt tells us in what direction p changes. So for dp dt greater than 0, this means that population is increasing. Conversely, for dp dt less than 0, this tells us that population is decreasing. Okay. And many of you already know that there is a third case, dp dt equals 0. And in this case, there is no change in p. Okay, and in this third case, for values of p that satisfy this, we're going to give these a name. So values of p satisfying dp dt equals 0 are called fixed points. Okay, so how can we interpret this system? So one thing we can do is we can plot dp dt as a function of p. Okay, so we put dp dt on the vertical axis and p on the horizontal axis. This is just a polynomial in p. So for p equals 0, dp dt equals 0. And for p equals 1, dp dt also equals 0. So don't worry for now what the open and closed circles mean. All that's important is that for p equals 0 and 1, dp dt is 0. Okay, and if you plot this function, dp dt looks like that, a parabola. Okay, so in between p equals 0 and p equals 1, dp dt is above the horizontal axis. So that tells us that p is increasing. So in this region, p is increasing. Okay, for values of p bigger than 1, dp dt is negative. So that tells us that p is decreasing. Okay, so we can also plot population p as a function of time. So instead of dp dt versus p, we can also plot population versus time, or t. Okay, so from our first graph, we know that between 0 and 1, population will increase over time. So maybe it'll look like this. And then above p equals 1, population will decrease over time. And each of these lines I'm drawing here is called a solution trajectory for this system. Okay, so we can already observe some qualitative differences between p equals 1 and p equals 0. If we start close to p equals 1, the solution moves towards 1. Okay, so we are going to call p equals 1 a stable fixed point. Okay, however, for p equals 0, if we start close to p equals 0, we actually move away from 0. So p equals 0 is an unstable fixed point.